Have you ever just stopped and wondered about the hidden rules that keep our universe running? It's kind of funny to think that one of the first big clues came from something, well, something you've probably seen 100 times. This is the story of how that simple little moment led one man to calculate the entire universe.
So, an apple falls from a tree. Big deal, right? Happens all the time. But for one person, this wasn't just a piece of fruit hitting the dirt. It was a question, an obsession, really. What is this invisible force that pulls everything down? And could that same force actually reach all the way out into space to keep the moon spinning around the Earth? The man who dared to connect those two ideas would change everything.
So here's our game plan for this explainer. We're going to start with Newton's early life, see who he was. Then we'll get into his groundbreaking laws of motion. From there, we'll see how he made that incredible leap to universal gravitation, how he had to invent a whole new kind of math to prove it. And finally, we'll look at the massive legacy he left behind.
All right, so where does a mind like that come from? Well, it didn't start in some fancy lab. It started in the quiet English countryside, with a kid who was, by all accounts, a pretty solitary and intensely curious thinker.
Okay, so picture this. It's 1665. The Great Plague is sweeping through England. Total crisis. The university in Cambridge shuts down, and a young Isaac Newton is forced to go back home. But this forced isolation, it turned into one of the most productive periods in the history of science. Seriously, in just 2 years, all by himself, he laid the groundwork for his biggest ideas. And at just 23, he started inventing a brand new mathematical language to describe a changing world. He called it the method of fluxions.
So now he has this powerful new tool, this new math. What's he going to do with it? Well, he's about to write what is essentially the rule book for reality itself. In 1687, he publishes this absolute giant of a book, the Principia Mathematica. You have to understand, before this, science was mostly just philosophy. People talking about why things happen. The Principia was totally different. It used cold, hard math to explain how things happen, laying the foundation for what we now call classical mechanics. It was Newton saying, hey, the universe isn't just something to wonder about. It's a puzzle we can actually solve.
And right at the heart of it are his 3 famous laws of motion. First, inertia. Basically, stuff likes to keep doing whatever it's already doing. A ball at rest stays at rest, a ball in motion stays in motion. Simple. Second, the one everyone knows, F equals ma. The harder you push something, the faster it goes. And third, action-reaction. For every push, there's a pushback. These weren't just theories. They were like the fundamental grammar for how the entire physical world works.
But as huge as those laws were, Newton was just warming up. His next idea was this breathtaking leap that would tie the heavens and the earth together with a single elegant rule.
He started thinking, okay, this force that pulls the apple straight down toward the center of the Earth, what if that exact same force reaches all the way out into space? What if it's grabbing the moon and pulling it, making it constantly fall toward us but always moving fast enough to miss? This was universal gravitation, a kind of cosmic glue acting on everything, everywhere. It's an incredible thought.
And the amazing thing is, it just worked. This one single idea suddenly explained so much stuff that had been a total mystery for centuries. Why planets move in ovals, not perfect circles. Why the ocean tides rise and fall. Even the paths of comets shooting through the sky. All these different puzzles, solved by one law. For over 200 years, Newton's law of gravity was the law of the cosmos, period.
Now, to really prove all this cosmic machinery worked, Newton needed that special mathematical toolkit he'd invented back when he was stuck at home. But here's the twist. He wasn't the only one who came up with it. And that little fact kicked off one of the biggest, nastiest rivalries in the history of science.
So the question that set scientific Europe on fire was this. Who really invented calculus? Was it England's hero, Isaac Newton? Or was it this other absolute genius, the German mathematician Gottfried Leibniz?
So let's look at the timeline. Newton, no doubt, got there first. He was working on his version way back in 1666. But, and this is classic Newton, he was incredibly secretive and just sat on his work for decades. Then Leibniz comes along, starts working on his own version, and publishes it right away. And what's really wild is that they came at it from completely opposite directions.
You can even see it in how they wrote it down. Newton's notation used these little dots and bars over letters. It worked, but it was kind of clunky.
Leibniz, on the other hand, gave us the dy/dx and that famous squiggly s symbol for integrals that every math student knows and loves, or hates. His version was just more practical, which is why it's the one we all use today.
And this is where the fight got ugly. Really ugly. In 1712, the most prestigious scientific group in London, the Royal Society, decided to settle the matter once and for all. The only problem? The president of the Royal Society was Isaac Newton. Yeah, talk about a rigged jury. Leibniz wasn't even invited to defend himself, and the final report, the one that called Leibniz a plagiarist, it was secretly written by Newton himself.
But time has a way of sorting these things out. Today, pretty much everyone agrees this was a classic case of simultaneous discovery. You had two of the greatest minds on the planet working separately who both arrived at one of the most important breakthroughs in human history. It wasn't theft, it was genius striking twice.
So we've got physics, we've got math, but Newton's impact goes so far beyond that. The man's curiosity was just boundless, and he completely reshaped other fields of science too.
He dove deep into optics, for instance. He was the one who proved that plain old white light isn't pure. It's actually a mix of all the colors of the rainbow. He also invented the first practical reflecting telescope, a design that's still the basis for giant observatories today. And of course, as president of the Royal Society, he basically steered the course of British science for decades.
And yet, for all his monumental achievements and his famously prickly personality, Newton could also show incredible humility. He famously said that his own work was only possible because he was building on the discoveries of the great minds who came before him, like Galileo and Kepler.
When you really boil it all down, what Newton did was fundamentally change how we see the universe. He took a world that seemed chaotic, magical, and unknowable, and showed that it was an intricate, elegant system, a system that could be understood, predicted, and described with the universal language of mathematics.
That was the true revolution. He didn't just look up at the stars and wonder. He measured, he quantified, he built a formula for it all. He didn't just observe the world, he calculated it. He showed us that the cosmos wasn't chaos, it was clockwork.
And Newton's story leaves us with this really inspiring thought. He proved that a single human mind, just driven by pure curiosity, could literally decode the laws of the universe. It kind of makes you wonder, right? What other huge hidden rules are still out there, just waiting for the next curious mind to come along and see them?